P factor versus torque. What are the differences? Before I start, I should let you know that I have a video on P factor and another video talking about torque, if you want to watch those videos afterwards. Let's start off with P factor. P factor, in simple words, is the tendency of the airplane to yaw to the left. The tendency of the airplane to yaw to the left. And let's take a look at this word right here, yaw. What is the meaning of that word? In simple words again. Let's go up here and it says yaw movement. Side to side motion of the plane. Side to side motion of the plane. So in this case, we have this aircraft right here. And I'm going to give you the explanation, or should I say, I'm going to tell you what the rudders do. And the rudders control the airplane's yaw movement about the vertical axis. The rudders control the airplane's yaw movement. This is the yaw movement, pretty much the direction where the plane's nose is pointing, left or right, about the vertical axis, meaning this imaginary line that is going from the top to the bottom of the airplane. And this movement is called yaw. All right. The tendency of the airplane to yaw to the left. Now, how can we fix this tendency? Simple. The rudders are used to fix the turning tendency. The rudders are used to fix the turning tendency. Why? Because, as I just said, the rudders control yaw. So what are we going to be using to fix this situation? We use the rudders. Now, what causes it? In simple words, the uneven thrust of the propeller. The uneven thrust of the propeller. And I have an illustration down here, and in order for us to understand this answer, let's read these two paragraphs. The right side of the propeller, meaning the blade moving downward, I'm talking about this one, produces more thrust. So it's pushing more air backward on the right side of the plane. The stronger push on the right side makes the plane's nose yaw to the left, because one side, I'm talking about the right, is producing more push than the other, in this case, than the left side. And let's look at this propeller down here. And I wrote this note that says propeller viewed from the pilot's seat. So yeah, let's pretend that we are the pilot, and this is the way that we would be looking at our propeller spin. So it's spinning pretty much from left to right. This is the motion that we're going to be seeing. So now that we read the explanation, let's summarize this. The uneven thrust of the propeller. So we know that in order for our airplane to move forward, we need thrust, right? So that's why the propeller is spinning, and we're going to be moving forward. We're going to be moving forward. So what this is telling us is that the right side, in this case, this half, is producing more thrust. So it's pushing more air backward, meaning, I'm being very specific, behind the, in the plane. So this side is receiving more thrust on the right side of the plane. The stronger the push on the right side makes the plane's nose to yaw to the left. So all that air being pushed on the airplane, specifically on the right side, is going to cause a plane to yaw to the left. To yaw to the left. So that's why simulating that we're taking off, let's say our airplane is gaining altitude, and pretending that we're on a flight right now, we are very familiarized with the words right rudder, right rudder, right rudder. Why? Because of the tendency of the aircraft to yaw to the left. So this is what would happen if we do not use enough right rudder. So we're taking off, everything seems smooth until the plane wants to do this. So that's why we have to use right rudder. Again, so what is causing yaw? The uneven thrust of the propeller. Why? Because the right side is producing more thrust than the left side because it's taking bigger bites of the air, in simple words, and that air is being pushed to the right side of the plane, to the right side of the plane. Now let's take a look at torque. What is torque? In simple words, the tendency of the airplane to roll to the left. The tendency of the airplane to roll to the left. I want to compare P factor and torque now. Torque says the tendency of the airplane to roll. Again, this is the action of rolling. Roll to the left. So in this case, the plane wants to do this. And on P factor is the tendency of the airplane to yaw to the left. So in this case, is the plane trying to move to the same direction, in this case, the left, but it's not rolling. In this case, the wings are not moving sideways. It's just, up and down. So yaw is just pretty much the nose wanting to go to the left and do this. The tendency of the airplane to roll to the left. Now, it says down here, the ailerons are used to fix the turning tendency. The ailerons are used to fix the turning tendency. So we know that if we want to turn, let's say we're flying and we want to turn to the left, we make sure there's nothing on the left side. So we say left is clear and we start turning. And if it's to the right, all right, right is clear. We see that there's nothing in the way and we turn to the right. So the ailerons are gonna be the movable surfaces that are gonna help us turn. So in this case, the answer says the ailerons are used to fix this turning tendency. So we're gonna be using the ailerons, in this case, the right aileron, to fight this tendency of the airplane wanting to roll to the left. Now, what causes it? In simple words, the air resisting the propeller's acceleration. The air resisting the propeller's acceleration. Now, I have to be honest in this part. Finding the reason why P factor happens was easier to pretty much find the answer. But with torque, it was a little bit confusing at the beginning, but because of that reason, I'm going to be giving you another non-aviation example to understand this concept better. And before I do that, let's read the explanation of this answer. So we're going to go sentence by sentence to understand this. The propeller spins to push the air backwards. So, well, I know this is a commercial airplane, but let's pretend that right here that's a propeller, right? So in this case, the propeller is spinning, and there's air being pushed behind. So this propeller, is spinning, and there's air being pushed. There's air being pushed. So that's one. Now let's go to the second sentence. Air is resisting acceleration. Air has mass, so it can't move instantly. So you guys remember we talked about air density, that when the air is colder, pretty much the air feels a little bit heavier. And when the air is warmer, the air feels lighter, right? So that's what we're talking about right now, the air density. And I'll read it again. Air is resisting acceleration. Air has mass, so it can't move instantly. So these propellers are moving at a high speed, and they are pushing air molecules. And because those air molecules have mass, that's why you can feel that resistance. In this case, a propeller feels that resistance. Now let's go to the third sentence. The propeller pushes against the air, and the air pushes back on the propeller. I'll read this again. The propeller pushes back against the air, and the air pushes back on the propeller. So to understand this part, I'm going to use a non-aviation example so we can understand this last sentence. In this example, I'm going to be using a drill. And before I use this drill, we have to understand one thing. Newton's third law. And Newton's third law says, for every action in this case a force, there is an equal and opposite reaction. For every action, in this case the force, there is an equal and opposite reaction. Okay, so let's take a look at the top part of this drill. And I'm going to start the drill, and I want you guys to see what's going on. So the drill is pretty much moving from right to left, right? From right to left. We just saw that.